And so, yeah, welcome everyone to Uncontrolled Moisture, the enemy of a healthy home. This course is approved for 1 hour in continuing education units, BPI, non-whole house, GBCI, as well as pending for AIA, health, welfare, and safety, which may make it applicable to your state-based design or contractor license. Today, I will be your moderator. My name is Brett Little. I am the executive director here at the nonprofit, the Green Home Institute. And the overall concept today is talking about our homes, keeping them healthier, keeping our clients' homes healthier, and doing that through resolving moisture issues. Big thanks to our top tier sponsor, Mitsubishi Electric. Mitsubishi provides all your heating, cooling, and filtration needs all in one system. Today's low-load homes require right-sized equipment that most systems, especially gas-fired, cannot meet. Mitsubishi has high-load, high-efficient heat pumps that dehumidify and cool in the summer and work in reverse to heat in the winter. Going ductless reduces costs and makes it easier to comply with Energy Star and LEED for homes and other green building requirements. Ductless mini splits can now be hidden, so your clients don't have to be bothered by the look of them. Ducted systems are hidden behind the walls to ensure a beautiful space and can be retrofitted right in to replace a furnace in an existing single-family home or a multi-family project. Hyperheat ensures efficient heat delivery down to -13, and backup strip heaters can kick in during rare but coldest of cold days. Each room of a house can customize comfort while still being all electric energy efficient for clients with different needs, and only heat and cool rooms that need it. This also works at multifamily and commercial scale with centralized variable refrigerant flow systems, or VRFs. They work great on large projects serving whole buildings. VRF technology that's using ventilation, like an ERV, can simultaneously heat and cool rooms as needed as the sun sort of moves around. One other cool thing is they're launching a product to serve with boiler systems, so you can still have that gas backup boiler, but then have the interconnectivity with their system. That's coming out new. We're going to be talking about that soon. MitsubishiComfort.com. Thanks to our other sponsor, Ava Windows. You've got aluminum recycled content, R7, UPVC, great performance. Check them out over at avawindows.com too. So excited to introduce our speaker today. Nikki Kruger is the Building Science Manager for Therma Store's residential and light commercial moisture control products lines, including Ultra Air whole house ventilating dehumidifiers and Santa Fe freestanding dehumidifiers. She has been involved in indoor air quality industry for over 15 years. She is a Resnet certified home energy rater, a member of the ACCA Manual Low Load Homes LLH Advisory Committee, and recently completed the ACCA Residential Design for Quality Installation Certification. So with that, Nikki, let's hand it off to you, and please take it away.
All right. Am I sharing my screen here? Here we go. Show my screen. There we go. All right. Well, thank you everybody for joining us today. I'm going to jump right into this because we have a lot of content to cover, and I want to make sure that if you have any questions as we're going over these slides, please go ahead and submit those, and I'd like to address those when we're on the slides if possible, but if something comes up at the end, we can do that then also. So today's discussion, we're going to talk about how humidity impacts our health, what affects the humidity in our homes, how traditional moisture management strategies no longer meet the real demands of occupants and modern building science principles, and how the ability to properly design and control a home's relative humidity can have beneficial impacts to the occupant's health, comfort, and property. And obviously we're hearing a lot right now about our indoor air quality, filtration, ventilation, humidity control. So hopefully by the end of today's discussion, how to control the relative humidity will be a little bit more clear, or you might be more interested in learning actually how to implement it. So a little bit more about Therma Store. We are located headquartered in Madison, Wisconsin. We invented the whole house ventilating dehumidifiers, the Ultra Air brand, in 1996. There's a gentleman named Ken Gehring who invented that, and he is on a forum called HVAC Talk. So if you have any moisture control questions or concerns or projects you're working on, he's known as Teddy Bear on there, and he's always happy to address issues. We also have the Santa Fe freestanding dehumidifiers. Those are typically applied to basement and crawl spaces. Quest is our commercial line of dehumidification and climate control, and then Phoenix Restoration Equipment as our restoration line. Really the point of this is we specialize in indoor air quality and dehumidification, and located right there in Madison, Wisconsin. So why is indoor air quality so important? And we've heard the statistics, especially a lot more lately with how much time we've all been spending in our homes this spring. But we spend 90% of our time indoors. We breathe approximately 3,000 gallons of air a day. Adults, 16 breaths per minute. And then when we get down to, you know, newborns and toddlers, they're breathing a lot more per minute. And whatever is in the air, we're bringing into our lungs. So we really need to think about that quality of air, especially when we're spending this much time in our homes. So there's a gentleman, Caleb, that posted this article on a group called HVACschool.com. If you haven't been to that website, I highly recommend it. Great information. But ventilation, filtration, and humidity control, the holy trinity of IAQ. And it's a really, really good article. And I think we all hear a lot about ventilation more and more because code and ASHRAE 62.2 and what's the right amount of fresh air. We know we need some. Filtration, a lot more. We're seeing the high efficiency filtration automatically added to new homes. But humidity control is one of those that we want to design our AC system to remove as much as that moisture as possible when it's running. But the reality is there's a lot of times when that air conditioner isn't running and removing moisture, and we're going to have a hard time keeping that humidity in check. So it's a really great article. I highly recommend it. And there's a lot of research articles out there on the effects of relative humidity to our health. Right now, we're hearing a lot with COVID, that 40 to 70% relative humidity. And I caution against just going by relative humidity because it's all relative to the temperature. So if somebody is chasing 70% relative humidity in the wintertime, they're going to be in a world of trouble trying to dump a lot of moisture in Wisconsin, Minnesota, Michigan into their air. And 70%, even in the summertime, we're going to see here with the different recommendations, is pretty high. And there's a lot of other mold and fungi and off-gassing and a lot of other things that once we get above that 50 to 60%, we could be causing a lot of other problems in our home. And so we can't always just focus on chasing that one thing. So here we just kind of talked about these different organizations. We have American Medical Association, the American Lung Association, EPA, all recommend around 50%. ASHRAE 60%, but then we have a health chart that'll dive into a little bit deeper. And then Building Science Corp gives that range of 25 to 60%. And it's really important that we control the relative humidity in our homes for our health, our comfort, our personal belongings, and the structure of our home. And the reality is moisture is the #1 detriment to buildings. And a lot of times, you know, what's inside of them. So we really need to think more strategically about how we're going to control that relative humidity. So here's the ASHRAE chart, health and well-being, and it gives that optimum zone there, 30 to 60%. But you can see really that 50% is really ideal for controlling bacteria, viruses, fungi, mites, respiratory infections. So if that can be our goal of where we're reading the humidity, because obviously we're going to have a sensor somewhere that's trying to control, hopefully, that relative humidity to 50%. If we can get that in that space, then obviously the spaces that are farther away from where that sensor is might go up a little bit, but at least we can keep it below that 60% for sure.
Nikki, I've seen this chart going around a lot, and I always struggle to understand if the big red lines are bad or good. Can you just elaborate on that real quick?
Sure. So the wider the lines, the worse it is. So that's why if you look at that 50% range where there's hardly any lines and the lines that are on there are really narrow, that's where we really want to be. As they grow in size, both ways, that means that there's potential for those bacteria and viruses when it's really dry or really wet.
Do you know on the viruses if that's true that they're actually talking about completely different kinds on the swings of those?
I think it is different kinds, but I think the potential is there more no matter what, and I'm not sure what kinds they're talking about, but obviously there's so many different viruses and bacteria out there.
Right, thank you.
Yep. So mold spores and dust mites thrive when relative humidity exceeds 60% for a sustained period of time. And we're going to dive a little bit more into dust mites here, because the reality is common household dust mites may be a factor in as many as 80% of asthma, hay fevers, and other allergic ailments. So if we can control dust mites, and somebody has, typically what they'll say is, I have indoor allergies. Someone might say I have outdoor. Well, indoors a lot of time is affiliated with dust mites. They are considered the most potent allergen in household dust, and people are actually allergic to their droppings, not so much the dust mites themselves. And they live and multiply easily in warm, humid places. And if we keep that relative humidity below 50%, they die. So, I mean, automatically we can control dust mites, which leads to indoor allergens, a lot of asthma and other allergies, if we keep that relative humidity in our homes at 50% or less. And an important area when we're looking at our homes is where we spend a lot of our time, and obviously that's in bedrooms. So we really need to concentrate on taking readings and understand the relative humidity in our bedrooms, where, you know, 10, 12 hours, and children possibly even more spend a lot of their time. So mold is definitely an interesting one, and really what we're concerned about with mold is a lot of time of the microtoxins and the VOCs that they kind of off-gas as they're growing on stuff. So there's a lot of health-related issues out there that are associated with mold, coughing, wheezing, I mean, indoor allergy kind of symptoms, but definitely can be affiliated with mold. And so basements, crawl spaces, areas like that, wherever we might not be getting, we might be getting some bulk water or drainage issues, we really need to make sure that we're resolving those quickly as soon as possible to prevent mold growth as much as possible. And off-gassing is a big one, and one that we, I think we hear more and more about, because we're talking about ventilation and what the right rates of ventilation are. And a lot of that is because we want to dilute and also try to get rid of as much of the chemicals that are off-gassing in our home or that we're generating. So formaldehyde is a big one. Usually the higher the relative humidity, the quicker our products in our home are going to off-gas, and a lot of times that is formaldehyde. So if we can control the relative humidity, that will slow down the off-gassing in our homes, but we're still going to need proper fresh air ventilation in order to dilute and get rid of the chemicals in our homes. So, oh, go ahead.
Well, actually, it looks like you're about to get into it, and maybe I can just ask to make sure, but you had mentioned something about relative humidity not being the best measurement, depending on temperature, and so that kind of left me wondering, what is the best measurement? You know, what do we do? And so maybe you're going to get into it. I am going to
dive into that. We're going to dive into relative humidity and dew point to understand a little bit more. And I'm going to start, and that's perfect, because I'm going to start with some definitions just to make sure that we're all on the same page. So the sensible load is the temperature you feel on your body and is measured by a thermometer. So usually your thermostat in your home is running based on that sensible load. It's the temperature you feel. And then the latent load is the moisture, and is often referred to as the relative humidity. And this is much more challenging to try to control with a thermostat that is trying to be run that air conditioning system based on that sensible load. But latent load is the moisture we feel. So when they say it's not the heat, it's the humidity, it's the moisture. When you like right now, even my glass right here, if you can see, I mean, I've hit dew point on this glass and I've got moisture going down, and we're going to get a little bit more into that here. So another concept that's important is a pints a pound the world around. So when we talk about maybe 70 pints of dehumidification or 70 pounds, it's the same thing. And this concept is really important for ventilation, and that's the 1 CFM out is 1 CFM in. Unfortunately, I got a good lesson in thermodynamics this past weekend with trying to set up a tent in the backyard and use an air conditioner to see if we could keep it cold, and it just doesn't work. So lessons learned, but it was a good attempt. So right here, hot goes to cold. We can't fight thermodynamics. Wet goes to dry, and high goes to low. So in the hot season, the humid season, all the pressures are trying to come into our house because we're typically air conditioning, which is making it drier. And then if we're exhausting air, that means we're sucking in air from the outside. So thermodynamics in the hot, humid season, and even in the shoulder seasons, plays a big part in how our homes work. So relative humidity. Relative humidity is relative to the temperature, and it is the measurement of the amount of water in the air at a specific temperature. So if we have on the left-hand side here, 85% relative humidity at 50 degrees, as soon as that air warms up, the warmer air can hold more water, and that same amount of water goes down to 43% relative humidity. And so when we look at our homes and we have an attic and we have our living space and we might have a basement or a crawl space, and all of those could potentially be different temperatures if they're not within our building envelope and being conditioned, there could be different relative humidities in all of those spaces. Crawl spaces are typically a little bit cooler, which automatically means they're going to have a higher relative humidity in them. Our attics, if they're not in the conditioned space, are going to be hotter typically with lower relative humidity. So it's all relative to a temperature. If someone calls me and tells me that their house is at 70% relative humidity, my next question has to be, what is the temperature? So I can get a better idea of actually how much moisture is in that air. And that's when we get into dew point. What we're concerned about is how much absolute humidity is, or moisture is in that air, and at what point am I going to start seeing condensation? So the dew point is what the air temperature would have to be for the relative humidity to be at 100%. And unlike RH, the dew point does not change with the air temperature, which it makes it more of an absolute measure of the water vapor in the air. So if you have condensation, like my glass right here, the dew point is above the surface temperature, and now I have condensation. And if you keep that dew point below the surface temperature, then there won't be condensation. And so I do a lot of work in encapsulated crawl spaces and talking to homeowners and contractors about the need. And a lot of times if you go into a crawl space, you're going to see a lot of condensation if it's vented. Because we have that warm air with a lot of humidity coming into it and hitting possibly some duct work that's not properly insulated, water pipes. If the HVAC system's down there, it might be actually on the HVAC system. So we see a lot of condensation issues in certain places in our home. And it can happen in the walls as well if we're not air sealing them. correctly and putting our vapor barriers where they need to go, we can have issues. So what we like to look at, and this is actually from Ken Gehring, Teddy Bear on HVAC Talk, the inventor of these DHUs. He likes to watch the dew point maps a lot across the country. So this was last September. And if you were to look at a climate zone map and also this dew point map, you would see it pretty much lines up for our moist areas on that climate zone map and with our dew point map here. So last September, end of September, probably not a lot of air conditioning running, especially as we get up to the mid-Atlantic, the Northeast, and the Midwest, but we've got some really high dew points. So as soon as you get above 55-degree dew point, that's when we start becoming uncomfortable and there's a lot more moisture in the air. So an ideal dew point in our house is 55-degree dew point. So if we're not running air conditioning at this time, we're going to have to figure out other ways to dehumidify our homes. So if we were bringing in 100 CFM of fresh outdoor air for our ventilation rate, depending on where you are in this map, you're going to need about 1 to 6 pints an hour of dehumidification in order to control the moisture in your home. So if you're down in the southern tip of Florida, you probably could be running at peak load still in September, obviously. But as we get up to the Northeast where we've got 70-degree dew points, we're probably not running a lot of air conditioning. So dew point maps are really important to really show us really how much moisture is in the air. And this was just March 18th, early spring. And the upper left is the dew points, and the down below on the right is the temperatures. And you can see we've got some high dew point temperatures there, but we've got really mild temperatures. And again, not a lot of air conditioning probably running at this time. So sources of moisture, there's a lot of sources of moisture. Construction moisture is the first and foremost that we need to deal with in new construction, and especially if we're closing up a building in late spring, summer, we're going to have to be dealing with a lot of wet materials, and not necessarily wet because it was rained on, but they've all absorbed a lot of moisture from just sitting in exposed high dew point conditions. So this, as much as a ton of moisture can be released by the lumber, concrete foundation, and drywall as it dries out. And then again, we get the seasonal storage effect. So when our houses were built to breathe and they were leaky, as long as we were to wet and dry, our houses were okay. And then we decided to add air conditioning to our homes, and that caused a lot of issues in homes. But our homes are always going to be absorbing moisture during the humid season. And then if winter comes along and we have a leaky house, it'll dry out, and then we'll start the process again. But if we can't get our houses to dry out, then we're going to have to deal with this seasonal storage effect as well, which can be 6 to 16 pints of water per day from seasonal storage alone. And then basement and crawl spaces are also a major source of moisture, and there needs to be a lot of attention to detail in waterproofing those and as much as possible. But the reality is it's below ground. They're always going to be absorbing moisture, and hopefully not bulk, but we are going to get vapor in those spots, and we're going to have to address them. So this is from an article Brian Orr from HVAC School wrote, and why is relative humidity in a house high? So we have low heat loads, which means we're running at partial or no load conditions. So our AC isn't running very much, and when it is running, we're not getting a long enough run time for water to actually go down the drain. And we'll talk about that a little bit more also. Systems oversized, even if you are sizing equipment to Manual J best practices, Manual J automatically oversizes about 15%. And then we have HVAC contractors. that oversize on top of that, because we do get some hot times of the year. 4th of July, you have 20 people over for a party, AC's not keeping up, they don't want the call. So there's a lot of oversizing up to, I mean, I think I saw an article that Joe Steenbrick did from Building Science Corp that says, you know, 30 to 50% we're oversizing our systems, which we know, and we're getting better at. But even right sizing, according to Manual J, is still a little bit oversizing. We have humidity entering the home from the outside. We have people inside that are generating humidity. We're not utilizing our spot ventilation as much as we should be in kitchen and bathrooms to get rid of that. So in a bathroom, it's not just while you're in there showering. It needs to run about 20 to 30 minutes after you leave that space for the moisture to really be extracted from that space. We have really energy efficient HVAC systems with high sensible heat ratios, and we're going to go into that a little bit more. We're not getting enough total dehumidification because of that, and low space temperatures. So basement and crawl spaces, typically we don't need a lot of air conditioning. You actually put colder air into those spaces and you're automatically going to increase the relative humidity. And when we can't rely on our AC system alone to dehumidify. So people add about 1/4 of a pint of moisture from breathing and about another 1/4 pint from activities to a home per hour. So we've had a lot of people at home for a significant period of time the last several months. So a lot of moisture being generated, cooking, a lot of cleaning going on. And so we estimate about a family of 4 is about 2 pints of moisture to a home per hour. So we can design, we can think about this when we're designing our systems, and we can design based on that. The challenge is we can't design based on how people truly live in their homes. So this lady liked to hang up her clothes every week in her 400 square foot apartment and dry all her clothes in the house. So this was a completely oversized HVAC system. There was a lot of things working against this space, but again, this did not help the moisture situation whatsoever. And then we have a lot of plants, and again, we can't control how people are actually going to live in their homes. So our houses have a moisture balance. So again, this goes into that wet and dry and wet and dry. And the tighter we're making our homes, the harder it is for them to dry. And so ventilation will dry a home in the drier season, in the heating seasons. But typically you're always going to be adding to the moisture load, even with an ERV, which we'll go into in the humid months. So we're losing that capacity to dry our homes. So we wet, we dry, we wet, and then it's a losing battle. We can't dry anymore. So, and I'm currently living in the Northern Virginia area, which I moved here about 3 years ago. And it has been several rainy seasons, and I'm getting calls from developers and building owners, homeowners that have never had a moisture problem in their homes before. And because of all the rain we've had the last several seasons, we're just getting that tipping point or dripping point of our homes can't dry. So the ultimate goal in every energy efficiency building standard program is to build a tight envelope in order to reduce the amount of runtime on our HVAC systems in order to save energy. The goal is to save energy. But the result is typically we're using far more energy efficient HVAC equipment to meet certain building standards, which has a really high SEER, which we'll talk about how that reduces our moisture removal. We're now in more partial to no load AC system conditions, even in hot, humid climates. So we're not running the AC as much, which is the goal. But the result is, because we're not able to remove as much of the latent or the water from the AC systems. We're trying now a strategy a lot more to overcool and to remove moisture, which can lead to a lot of problems as well. And we'll go into that a little bit more. So advances in our building construction is equaling low sensible load homes. So a lot of times when someone talks about high performance home or low sensible homes, or low load homes, it really means low sensible load homes. All these construction practices here, continuous insulation, airtight construction, better windows, ducts and conditioned spaces, all those are reducing the sensible load on the house, which is the temperature we feel, but ultimately might not be reducing the moisture load on the house. So we always have to remember when someone says, a low load home, it really means a low sensible load home, and not low latent. So as part of the low load homes, and we kind of touched on that in the bio, there is a new ACCA manual out called Manual LLH. And basically it assumes Manual J, Manual S, Manual D, all your other manuals, but it helps guide on how to size systems and design systems for these lower load, high performance homes. Because there's a lot of strategies that you need to think about, air movement, filtration, ventilation, making sure that people are comfortable in that home with smaller systems that typically aren't going to run as much. So this is about the sizing guide. So LLH starts at about 1,500 square feet per ton, which, coming from the HVAC background and industry, there's not a lot of HVAC contractors that feel comfortable designing systems based on these square footages. But that's where we really need to get. But then there's all these other things that we need to tackle as part of that. But again, this is our low sensible cooling and heating strategies. So we do have builder programs like the EPA Indoor Air Plus. It's a great program. Here you can see highlighted where we talk about where they talk about in warm humid climates, having a dehumidification strategy to control the relative humidity to at or below 60%. So they're saying either a dehumidification system or an HVAC system equipped with additional controls to operate in dehumidification mode. What you need to know about dehumidification mode, for the most part in most systems, means overcooling, running the system longer in order to remove more moisture. And that can be a tricky strategy because what I've seen a lot, especially in the mid-Atlantic, and as you start going more south, is, if you're overcooling, you're creating colder air, which can start condensing on spots. And you're not always, I've seen where ductwork isn't always insulated enough, and we start getting condensation in places. So, and you can't overcool to the point where people are becoming uncomfortable as well. So it's one of those that we should set up our systems to remove as much moisture as possible when they're running, and overcooling a little bit is okay, but the reality is it's probably not always going to be able to keep you at that desired RH that we're striving for our health and comfort and property protection. So I found this data here, which I thought was very interesting, and I think we're going to see even more of this, and hopefully there'll be some more updated data. But homeowners or home buyers are more willing to pay for a healthy home. I think people are becoming more and more thoughtful about their health, especially given the current situation. And to some extent, they assume they're buying, especially if it's a newer home, they assume they're buying an energy efficient home. I mean, codes are getting to the point where we're building high performance homes. So people assume that a home is going to be energy efficient, but what they want to know is it going to be a healthy home as well? So how do we achieve lower humidity at home? And this is the other part of Brian Orr's article. We need longer run AC run times. So we might need to downsize that AC system to get it to run a little bit longer, work a little bit harder. Colder AC coils. So your really energy efficient AC systems typically have a higher coil temp in order to get to that sensible quickly and not use as much energy than a system that maybe an older system or a system that's been adjusted to run a colder AC coil and maybe run a little bit longer. So we need obviously tighten up our homes. We need less moisture coming from the outside. The next one's hard, less moisture being generated on the inside. We can't control how people live in their homes. Everybody lives differently. I control the thermostat differently than my husband controls the thermostat. Higher indoor temperatures, typically you can set your indoor temperature higher if you're controlling the relative humidity. You will feel just as comfortable as at a higher thermostat temp if you get that relative humidity around 50 to 55%, and you can increase that thermostat temp. Some dedicated dehumidification when needed, and we need to utilize that spot ventilation as much as possible. So strategies for controlling moisture: air conditioning, whole house dehumidification, area dehumidification, whole house ventilation, certain times of the year that will work, and spot ventilation. So I'm going to kind of go through these a little quicker here. Air conditioning, again, is designed to get to that temperature set point, that's sensible. Newer air conditioning systems have dehumidification set points, but again, most of the time they are overcooling in order to dehumidify. And the days that we really need to be most concerned about the relative humidity is kind of that 70 and raining scenario. And depending on where you live, that can last for significant periods of time in the spring and in the fall, where we're not running air conditioning. So our partial and no load conditions is where we really need to be thinking about how am I going to control the moisture. So mechanical systems typically need about 14 minutes of runtime before what is considered effective dehumidification happens. So we need to load the coils of that AC system, and then water needs to start dripping down and going down the drain. And so when someone buys an energy efficient home or a low load home, a high performance home, and their air conditioning starts running for longer periods of time, so they're going to probably, sometimes start questioning, did I really get an energy efficient home? Is this right? But we need to educate that, we've sized the system a little bit smaller. It's going to run for a longer period, but you're going to get good dehumidification and moisture control, possibly when there is a sensible load. You always have to have a sensible load in order to dehumidify. So, but we need those longer AC run times in order to actually get water going down the drain. So SEER, most of the higher performance building programs really encourage these higher SEER HVAC systems. And so what you need to understand about these systems is they're larger coils that are very efficient at getting to a cooler temp, which means less run time. So it's, you lower that thermostat a couple degrees, it's going to come on and it's going to quickly be able to get to that lower temperature. And these coils on these higher HVAC systems typically hold about 1 pint of water per ton. So if you have a 5-ton system, you have 5 pints or pounds of water on those coils. The coils don't get as cold as the older AC system, which means less water being removed and going down the drain. And how they kind of sneak in a higher SEER rating is when the compressor shuts off, the fan runs for 1 to 3 minutes afterwards. And basically they're getting points for evaporative cooling. So if you live in Arizona, that evaporative cooling it could be a big benefit. But if you're living in a more humid climate, getting all that moisture that's on those coils re-evaporated back into the air, which again, you have a 5-ton system, that's 5 pints or pounds of water being blown back into your living space, and it can actually increase the relative humidity by up to 10%. So it's important to know, how these higher SEER systems are working when it comes to moisture. So best practices for designing systems. We have our design indoor cooling temp, the outdoor temp, which is the peak load. So that design outdoor cooling temp is going to be the peak outdoor temperature design that we're going to design our HVAC system around. And what's important to know about that is when we're using this best practices to design our AC system, typically those conditions are about 1% of the time. So we're designing systems that are going to run like we designed them 1% of the time. And then we got to figure out how we're going to control, especially the relative humidity, that other, 95, 98% of the time, 99% of the time when we're not at our peak conditions. So we're going to go through our design, how many people are in the house, how much fresh air ventilation I want, depending on what standard I'm using. And then it's going to tell me how many total BTUs of cooling based on sensible load and latent load. And the reality is most homes with our sensible and latent loads are becoming closer and closer in number. So we're not at that, 29,000 versus for sensible and 7,000 for latent. They're actually becoming quite a bit closer, which is challenging to design our AC systems for when they're basically designed to get to that, to really focus on that sensible, that temperature load. So this is where we're seeing really the need for whole house ventilating dehumidifiers. So the dehumidifier integrates with the HVAC system, and it's only going to focus on the relative humidity. Set up that air conditioner to remove as much water as possible when it's running, but when it shuts off and the relative humidity is still too high, then the dehumidifier will come on and dehumidify the entire home. So in the evening time, a lot of times you go to bed, someone gets up, starts cranking down the air conditioning because they're uncomfortable. It usually isn't a temperature thing, it's a relative humidity thing. And our shoulder seasons, that's when we're really going to see the dehumidifier shine and do the work. So we have EPA recommending that 35 to 50%. 50% is summertime, and that's where you're going to be most comfortable and healthy. We can't rely on air conditioning alone to control the relative humidity in our homes anymore, especially how tight and energy efficient we're getting our homes. And then we have a lot of partial load conditions, but we need to be able to control that relative humidity. This is a resource, it's dpcalc.org. And so on the left-hand side here, it's a website you can go to. I can go in and put in my conditions. So basically, I pulled these conditions on the left-hand side from our dew point map. So we had 72 degrees with a 68-degree dew point, which is 87% relative humidity. And this is pretty typical conditions for spring and fall in a lot of areas. Where we call green grass climates, anywhere that you're getting about an inch of rain or more, which is basically what we saw on that dew point map, where we saw the higher dew points. But if you go on the right-hand side here and you look at that mold risk, the third line down, you can see that we have about 5 days at those conditions where we've got a potential mold risk. So this is a really great resource to play with. Again, that's dpcalc.org, to kind of play with different conditions to see how many days till I'm at a mold risk. And then we also have a resource, it's a free app. It's Ultra Air Psychrometric Calc. You can get it on your iPhone or your Android. And this is based on ventilation. So The inlet is the conditions that are outdoors. So outdoors, it's 88 degrees, 65% relative humidity with a 75-degree dew point. The outlet is what I want in my house. I want it to be 74 degrees, 52% relative humidity. And really what I'm going after is that 55-degree dew point. And the flow is how much fresh air my ventilation rate is. So I'm saying that the ventilation rate here is 100 CFM. So this is telling me based on those conditions that I'm gonna need about 106 pints of water removal a day. This is solely based on ventilation. And then you take in your occupants. So if you have a family of 4, then you're gonna have to add that number to this, and it'll give you, how much dehumidification you're going to need. So if we look at in summer conditions, 93 degrees outside, 74-degree dew point. I want 75 inside with that 55-degree dew point. My ventilation is 100 CFM, and it's telling me how much water removal I'm going to need a day. Now, at these conditions, at peak load in the afternoon, that air conditioner is probably, hopefully, keeping up and doing a good job, depending on how tight the house is, how low load the home is. But it's doing a pretty good job, hopefully, of removing some moisture if it was sized correctly. It's going to be, and the challenge is going to be, overnight potentially. And then we have where we get into those partial loads where we're going to get some AC short cycling, 85 degrees. I want 75 inside. The dew point outside is 70. I want 55-degree dew point inside. So here it's showing at that flow of 100 CFM, I'm going to need almost 75 pints of water removal a day. So between my air conditioning and how the people are living inside, you're going to need that moisture removal, and you got to figure out how we're going to get that. And then we get into the no load conditions. So here we've got the 70 degrees and raining scenario. And again, at that 100 CFM, we need 91 pints of water removal a day at our no load conditions and 70 and raining. So that's just a tool you can play with. If you're more into grains than dew point, if you click on the little eye up in the corner, you can change it from dew point to grains. And you can also go from pints a day to pounds an hour. So it gives you some options to play with on that app as well. So a recommended install for dehumidifier, a whole house is, and there's a Florida Solar Energy study that was completed about 2 years ago on the most effective and energy efficient way to install a dehumidifier. And this has always been our recommended install, and that's a dedicated return, if possible, to the dehumidifier. You can use the dehumidifier for fresh air ventilation. They all have a duct for fresh air, except for our smallest pint unit, which is a 70 pint unit. And then we tie into the HVAC supply. And by installing it this way, it's the most energy efficient install, because we don't have to use the fan on the HVAC system in order to, when the dehumidifier is running. So AC comes on, shuts off, it's still too humid. The dehumidifier comes on, it has its own fan, everything in it, and it'll dehumidify. And then we don't have to use the largest fan in the house to move the air. So most energy efficient way to install is right here. And then this is just kind of a little illustration here that we're going to pull in that air from a dedicated return into the dehumidifier with its own fan. And then we can also program if we want to open up that motorized damper throughout the day in order to bring in fresh air. And this is a unit that we have that utilizes a heat exchanger in order to get to dew point faster. So it's really the most energy efficient way to remove water by pre-cooling that incoming air. And then we remove the water, it goes down the drain, and we deliver the dry air back into the supply and throughout the home. So we're going to jump into some area dehumidification, which is crawl space and basements. Crawl spaces is one of those areas that most homeowners don't ever think about and don't want to know about, but a lot of our air from below our house, crawl space and basements, 50% of it comes from below the home, so into the living space. It can contain a lot of indoor air contaminants, and that air is going to rise up into the home, and oftentimes there's some indoor air quality issues associated with that. According to Advanced Energy, vented crawl spaces were 19 times more likely to experience RH levels in excess of 70% than encapsulated crawl spaces. And this is two crawl spaces here in Northern Virginia that are habitat homes located right next to each other. The lots are right next to each other, same exact homes. Same number of people, and we encapsulated them. And one we used a code option for conditioning a crawl space, which was an AC supply strategy. And then the other one we used a small dehumidifier. And basically the crawl space using the AC supply ran above 70% for a large part of the spring, summer, and fall. I had to turn off the monitoring alerts. They were built habitat, very energy efficient, Earthcraft standard homes, and in both homes, the occupants didn't like to run air conditioning very low, and so when you're trying to put conditioned dry air into a crawl space, which that's colder air into the crawl space, it's automatically going to increase the relative humidity. And then the one on the left with the dehumidifier, we just set the dehumidifier and let it run, and it kept it very controlled. So again, there's strategies in code that might not always work for your application either. And this was just that dew point calculator showing crawl spaces. If we're bringing in that humid air into that colder space, we're basically at about 2 days till we're going to get mold in that crawl space if we're using ventilated crawl spaces. And then basements and green grass climates without a dehumidifier typically are going to be around 65 to 70% relative humidity during the spring, summer, and fall. It's below grade. We're always going to get the vapor through the walls, to the floor, concrete floors. Very, very important to control that moisture, especially below the house. And this is more looking at that basement and how many days if we were not doing anything in those conditions. We've got about 38 days until we're getting mold in that basement without doing anything. So crawl spaces, there's a lot of them in the United States, estimated 76 million already in existing, and we're building lots more every year. It's estimated that 53.4 of single family homes have a basement or a crawl space under part or all of the house. So it's one of those situations that we need to make sure that we're monitoring, that we're looking at, that we're addressing in homes automatically, is controlling that moisture below the house. Sometimes that'll resolve the issues in the rest of the house if we can just start with controlling it in the basement. So just some data that I pulled on foundations. This I think is just the Midwest in 2018, how many total new houses were built, and then the full or partial slab or crawl spaces. And we're seeing a lot more homes built on slab throughout the United States. And so that's an interesting situation where we're going to have to definitely be controlling moisture in that entire home versus just trying to address it initially in the basement or the crawl space to see if that resolves. And this is kind of hard to read, but I wanted to show that there is a huge opportunity to educate homeowners on dehumidifiers. If you go into a home and they have one of those portable big box dehumidifiers, there's a website you can go to, and I think it's on Energy Star, but there have been millions of portable dehumidifiers recalled in the last several years due to fires. A lot of people don't know that they have those dehumidifiers running, so make sure that you do your customer service and let them know to check that dehumidifier to see if it has been recalled. But there's a huge opportunity to educate and sell high performance dehumidifiers to homeowners. Something with more than a 1-year warranty that they're going to have to replace all the time. So multifamily, we do a lot of work in multifamily because we have an in-wall dehumidifier, and this was a case study here in Northern Virginia. Multifamily building built to the Earthcraft standard, constructed in 2015, and then 2017 they had one whole building that was having a lot of mold issues. And this is one of the interior walls when we went into this apartment, and it happened within a week. They actually had 5 units that look like this, and 2-stage systems, so 2 tons on about 700-800 square feet, because they were trying to run the 2nd stage and get dehumidification, and that's what they were kind of sold for that system. But as a result, you know, the residents were uncomfortable, and they just kept lowering the thermostat. And when we went in, we were at 75% almost RH and 66 degrees in this apartment here. And basically, again, people don't understand how, you know, the thermostat is their comfort control center. If I'm not comfortable, I'm going to raise it or lower it. That's all I know. And, you know, when you're looking at August, they're just going to keep lowering that thermostat because they're uncomfortable, and that's their only control they have. So we put in an in-wall dehumidifier that we specifically designed for multifamily, but it's gone into a lot of finished basements and other applications as well. They had a laundry room here in kind of the main space, so we could tie into the drain, plug it in. And then we data logged here. So what you can see is that solid blue line is the 50% relative humidity that we set that dehumidifier to. And then that dotted line was the RH outside, which you can see that obviously there was some pretty wet days there, but the dehumidifier was controlling that to 50% regardless of what was going on outside, and they increased that thermostat temp to, you know, 74 degrees inside, so they're much more comfortable. So I'm not going to spend a lot of time on ventilation. There's exhaust, supply, balance. We know we need ventilation in our homes. My only recommendation is cautioning against exhaust only, especially the humid times of the year, because we will be sucking in air through other cracks and crevices when we're doing exhaust only ventilation. So you got to be very careful about that depending on where you live. I know in heating dominated climates, exhaust ventilation has typically been recommended or more accepted, but we really have to be careful during those humid times of the year, which we get a lot of them, spring, summer, and fall. It still gets very humid when we're sucking in through those places. So our ventilating dehumidifiers are supply ventilation, so we're looking at putting a slight positive pressure on the homes. Filtering it with a MERV 13 filter can be fairly easily retrofitted, and again can possibly precondition that air a little bit too before delivering it to the home. So we often get a lot of questions, and I am actually dealing with a lot of high performance builders that have been using ERVs that tell their homeowners in the humid months to shut off their ERVs because it's contributing more moisture than they thought it was going to into the home. So it will always lessen the load. An ERV will lessen the load of moisture that's coming in, but it's always going to contribute to it. So it's not allowing that moisture from the outside to come in. It's going to depend on how dry the inside air is, how wet the outside air is, what your exchange is going to be that's going on, but it will always contribute to the load. So this is this was in Orlando, a house, NHB emerald green house that had an ERV in it, and they were experiencing, as you can see on the right side here, that blue line is the RH in the family room, so consistently above 60%. That green line is the dew point outside, so the relative humidity in the home was following basically that dew point outside. And we ended up taking out that ERV and putting in its place a ventilating dehumidifier, which you can see on the left-hand side here. Set it to 50–55% relative humidity, and we don't really care what the dew point is outside. We're just going to control the relative humidity in that space to the desired set point. And Armin Rudd did a study with the DOE, and basically what he said is the ERV is ineffective in keeping indoor RH down during the floating hours, which a lot of times is our overnight, mornings, shoulder seasons, when the difference between the indoor and outdoor absolute humidity is small. So it's humid inside. We're not running a lot of air conditioning to dry that air, and it's humid outside. And one of the questions that we often get is people are very concerned about the energy use for a dehumidifier. Red Calc is a great website. They have a lot of different calculators for resources on there. I use the ventilation electrical usage calculator to calculate the energy use. So 580 watts is for our 70-pint whole house dehumidifier. I said I was going to use it 210 days of the year, so probably a more warmer, humid climate. And I'm going to run it 20 minutes out of every hour during the day. So 20 minutes out of every hour. And then the average cost per kilowatt I put in is 13 cents. And at the very bottom there, you can see that the annual electrical cost is about $126 to run that dehumidifier. 20 minutes is only a guess. Some hours it might run a little bit longer. Some hours it's going to run less. So I just took a guess, but it'll be $126 for 210 days a year to run that whole house dehumidifier. And if you are familiar with Dr. Joe Seabrook from Building Science Corp, I attended one of his sessions last year, and it was an all-day session for a passive house at the Passive House Conference. And someone was really concerned about having to run a dehumidifier because they making their houses so tight and you're not running the air conditioning. And Joe's comment was 10 steps forward, 1 step back, and you cannot energy conserve your way to dry. It is going to cost you money to keep a house dry, but ultimately it's the protection of that house and the people inside of it and their comfort. So I really say that we're now at a time where it's HVAC-D. Our AC really isn't doing the D that it used to because we've made our homes so tight, and we've really greatly reduced the amount of runtime on our air conditioning. So I talked to a lot of builders and contractors, and it seems like if I need a dehumidifier, somebody did something wrong. And the reality is if you're building the house energy efficient, you're making it as tight as possible, you're sizing according to best practices, because that's what we have is manual J, and we're bringing in that outdoor fresh air we need in order to dilute the indoor air contaminants. The reality is if you need a dehumidifier, you probably did everything right. And we just need something to focus on those moisture loads now. And that is all I have. Did any questions come in, Brett?
Yes, definitely. We have a lot of questions.
And my contact info is up there too. So
right.
If we don't get to your questions, you can always email me or give me a call.
Yeah, definitely. We got a lot of questions. Are you able to stick around for a little while?
Absolutely.
All right, great, great. Well, before we get to the questions, and I see a couple more pouring in, but before we get to them, just real quick reminders here. For those of you taking your, need to get your CEUs, watching this now, take that survey that pops up at the end. The same one will be sent to you in email an hour later. Please just take it once. Even if you don't need the CEUs, we want to hear your feedback. And then those of you watching this in the future, not right now, get that quiz, get the 80% passing rate, and you can snag your CEUs. And as those questions are coming in real quick, just here's where you find it on our YouTube channel. Click the YouTube link, and on the left there, click the show more down in the description, and on the right, you will find the quiz to get your Con Ed. And again, a huge thanks to all of our members, our board of directors, all of our top tier sponsors, Mitsubishi Electric, Build Equinox, Serve 2, and Ream. Huge thanks to all of them to allow us to do what we do. So yeah, there are a lot of questions here. I got a lot of questions. I got a lot of notes I've written down. I certainly learned a lot. And I kind of want to head back to the beginning here a little bit and talk a little bit about dew point real quick. I mean, is there a way that it sounds like, as you were saying, relative humidity isn't necessarily the best measurement. And I'm even wondering, like, you get your thermostat in one place of the house and it's a totally different temperature than the other place of the house. So then could that same thermostat that's telling you relative humidity also mean an entirely different place of the house, and not necessarily the attic or the crawl space, also have an entirely different, humidity level? And then are there thermostats that just measure dew point and just get to what it is that we're trying to get to here?
Yeah, and I think that's where we'll see it. So relative humidity is hard to really understand for most consumers, homeowners. So if we try to get everybody to dew point, that is going to be very challenging. That's one of the struggles with trying to control something by dew point, is because we have to educate homeowners, and the education of occupants of any building is always challenging. But we know every night when we see the weather, they give the dew point, but nobody really understands. Everybody's like, well, what's the relative humidity? That's what they're trying to go by. But yes, I think you'll see controls for dehumidifiers probably go more towards dew point. And while we give control of the dehumidifier to homeowners, there really is nothing that you need to control, right? I mean, you set it to 50, 55%, and it runs. You shouldn't be messing with it. But everybody wants control of absolutely everything in their house, and they want it on their phone. So you have to give people control. But I'm working on a house right now in Maryland, and it's helping out somebody with a house, I should say. And all the rooms, it's a massive, massive house. All the rooms of the home seem to be around 45 to 50% relative humidity, and we have this one bedroom that's 60 to 65%. So there's something going on there, right? I mean, we've got to figure out what exactly is going on for that one room. So if we make our houses fairly tight and find our leaks, and that really helps us control the different parts. And then if we've got good communication and good duct design and that sort of stuff, that really helps control temperature and relative humidity throughout the entire home. So there's so much more that comes into designing and doing all that to really get even control throughout the entire house.
Just real quick, we talk a lot about homes here, obviously, but someone had some questions about how that relative humidity target or dew point target plays out in other applications, office spaces, warehouses, gyms, factories. Is it still consistent? Is that where you want to be, or are there other rules?
And I'm going to definitely, when it comes to more commercial, depending on what it is you're trying to achieve. But if we're looking at for human comfort and health, we should have that 55-degree dew point for sure. And when it comes to, we do a lot of work in fitness facilities, locker rooms, So yes, you definitely need to figure out the size of the dehumidification in order to keep that relative humidity down, those dew points in check, so you don't get mold growth in those. I mean, if you ever stay in hotels, the gyms in hotels are always the worst.
Right.
They're stuffy, they're super cold. I mean, again, we're trying to utilize the AC system. But if you're looking at other commercial applications, we specialize, our Quest line of dehumidifier really specializes in like water treatment plants, agriculture, larger applications. We have dehumidifiers that are, over 900 pints. So depending on what the application is and what you're trying to get to, it might be like, if it's electronics or in medical facilities where they can't go above 40% for certain things, there's different challenges there. So.
Great. Going back to ERVs, HRVs, ventilation, heat recovery, it sounds like, and I just learned this today, that there are dehumidification systems that have ventilation and heat recovery built right into them. So what is the, I guess, percentage, because a lot of times when we're talking about heat recovery systems, we're talking about what is the percentage that they typically recover? So maybe you mentioned it, but I didn't catch it. So
it is confusing when I say there's that heat exchanger core, because that core is solely being used to pre-cool the incoming air from the living space. So it's not we're not doing a heat exchange based on ventilation. It is solely to pre-cool the incoming air, which allows us to get that air to dew point faster on the coils, so we can remove more water using less energy by doing that. So it's not the same sort of heat exchange application when you look like at an HRV. It is the same technology, but we're using it for something completely different.
As far as the ventilation side, then, could you still use it for a balanced system, or is it only bringing air at certain times?
Yep, so we are a supply only ventilation strategy. So in most humid climates, the building science recommendation is a slight positive pressure, because we don't want to be sucking in air through our walls where we'll get condensation and we don't know potentially where it's at. So balanced ventilation in humid climates is typically not strictly balanced. You might use an ERV that you can put a slight positive pressure on that home, but we want a positive pressure. So we have an article on Green Building Advisor on how to integrate a dehumidifier and an ERV, if that's what you want to do. We recommend keeping them separate, but sometimes people really want the two to be in line together, and we have an article on there on how to do it and the pros and cons of all of them. But typically, I mean, if anybody watches Matt Reisinger, in his homes, his Cadillac is an ERV and a dehumidifier in all his homes. And if you can't afford both, then he recommends the ventilating dehumidifier.
Interesting. Real quick, when talking about units having dehumidification set points, do you mean the thermostat or the actual HVAC equipment?
So the thermostat for that HVAC equipment, so that HVAC equipment has to be able to ramp down based on, it's really kind of widening the dead band is what it's going to do. But that thermostat will have an RH reading. And if it's not being met when the AC kind of reaches that temperature, the air conditioner fan typically will slow down and it'll still keep running, but producing a smaller amount of air, but it's cold air in order to try to remove more water from it. So you can't just put a thermostat that has RH on it onto like a single stage HVAC system. That they kind of have to be compatible. You have to have the multi-stage two-stage equipment in order for that to happen.
Mm-hmm. Great. You mentioned a lot of different tools and resources out there to diagnose existing projects, and I suspect plan for new. So manual S, it sounds like, really is the good one to use with your HVAC for designing, proper dehumidification. Is that correct?
Well, so manual J is going to give you what your loads are. Now, what I will say for manual S, if anybody has a copy of that, if you go to page 49 in manual S, I think there's about 6 to 8 pages on how to design or size a dehumidifier for your projects. So most people don't even know what's in there. A lot of HVAC contractors don't know what's in there. I will say that we are currently working with ACCA on, they are reworking manual S right now, and we're working with them on that. So, but there are guidelines in manual S on how to size a dehumidifier. And to be honest with you, that's one of the #1 questions we get is, well, what size dehumidifier do I need? And really, to be honest, that's a whole other presentation that we have.
I would say I think we should have you back for that one, because I'm like thinking like, okay, to design this, do I need to go read a really large manual, or is there's the tool that will help me design it, but I need to read the manual to understand how to use the tool? Like, is it I have to do all the math myself using the manual, or I guess just a high level?
It's really, there's a lot of things that go into designing a dehumidifier, and it all depends what the ultimate goal is. If the goal, like sometimes with multifamily, their goal solely is to not grow mold.
Right.
So that might be sizing a dehumidifier differently than a $5 million house where the architect and the mechanical engineer and the builder are really after the ultimate comfort for their client.
Sure.
It's different. So, we have different design strategies and kind of, there's ballparks. There's no real governing body that says, okay, for this, we go by square footage in all of our specs. So if I say a 70-pint dehumidifier whole house, it's 1,800 square feet. But that's just general, because there's so many factors that go into really what the moisture or latent load is going to be in that house. So we work really closely with a lot of people, emails, phone calls, on helping understand what they're going to need. And I will say that, one great resource is Teddy Bear on that HVAC Talk forum. Ken, I think, is 81 years old now, and he loves talking to people about their moisture control issues, and he will be the first one to tell you when a dehumidifier isn't going to fix it. I've got pulled into a lot of projects where he's asked a lot of questions, and I went and checked it out, and the reality is they need to do some air sealing. They need to, there's a lot of other things that need to be fixed before a dehumidifier can be successful, because we want it to be successful.
Sure. So talking about, you had made a comment about there are more slabs, I guess, in America now than there are crawl spaces and basements, which I am thrilled to hear, because that is something, we try to help people with. But you made a comment about how now that shifts the water issue from the basement to the whole house, which interestingly, one of the benefits we say is, well, now you don't have, like here in Michigan, we have the Michigan basement, right? It's always moldy, always. I grew up in it and sneezed all day. And so, it's like now we can get rid of that thing. You don't have to worry about it, cut costs. So it should help with moisture problems. But you had mentioned now the moisture, at least what you said it is, maybe that's coming up now into another area. And then I just want to kick in another attendee's question in lieu of that, saying, and how do you deal with these things with like, trailer park homes as well, or modular homes?
Sure. Well, so, the slab is cement, right? You are always going to have evaporation from cement. I think it's, and I'm not sure, I know that the Concrete Association, I think it's about 5 pints or pounds of moisture and I'm not going to get this right, per 1,000 square feet of concrete, and I'm not sure if that's a day or an hour, but you are always going to be getting moisture evaporating into the home from concrete. There's no other way around it. No, I don't care how much you insulate it underneath and all that moisture, it's always going to be absorbing moisture and releasing moisture. It'll slow down over time, but it's still going to do it. And then again, we still have moisture out in the air that's getting into our houses. So there is a chance you're going to need a whole house dehumidifier, depending on how tight you've built, what the people are doing in the house, and what your ventilation strategy is, and how much moisture is in the air outside. So it's just a matter of, we know that 50% of the air in our homes in a basement or crawl space comes from below the house. But now that we're on slab, we do minimize, hopefully a lot of that moisture and indoor air quality issues, mold, pests, all that stuff. But we might just have to think about our whole house now for moisture control. And then modular, if it's modular homes, it might be an in-wall dehumidifier if it's a smaller space. Or if there's a mechanical closet or something like that, we do have the ability to fit really small dehumidifiers in mechanical closets. And whether we tie into the ductwork or we give it its own ductwork just to move from air one end of the house to the other, we've done all kinds of things. When I look at this, like small spaces, it's really no different than an apartment, because that's always just a small space of its own, right? It's a small house. So we just have to look at different strategies to see. But the in-wall dehumidifier is definitely being used more and more, and you don't have to do ventilation with it. But what's nice is it drains the condensate by itself. And depending on the situation, it can either be locked out, like in multifamily, where they don't want anybody touching the controls, or it comes with just regular screws as well for the control. So
here's a comment. Question: dehumidifiers have a heat load out to the space. Is it better to upsize the HVAC system to account for this, or to design use a humidifier that ejects the heat load to the outside?
Okay, so like we said, most HVAC systems are oversized right now. So unless you are building an extremely tight house, and that HVAC system is probably a little bit undersized, you don't need to take into account most of the time the BTUs added from the dehumidifier. The system is already oversized and can handle it. So we don't recommend that typically at all. And then the reference to ejecting the heat outside, if that is a concern, we do have that SD12 model that does just that. It discharges the heat from the dehumidifier to the outside. The challenge with that unit is it's 180 pints of dehumidification, and by discharging that heat to the outside, we have to remember, in the Midwest and the Northeast, typically when we need the most amount of dehumidification is in the shoulder seasons, in the spring and fall, and a little bit of heat's a good thing. So we just have to be careful about that as well, because if it's cool and we're discharging that heat to the outside, we're going to be running that dehumidifier in defrost mode more.
Great. Just kind of going back to foundations and more prescriptive strategies. Specific question here: would you recommend a moisture barrier above the slab with insulation XPS under the slab, or any kind of strategy like that to help?
I don't typically get into that sort of thing because there's so many different strategies.
Sure.
I would say, again, when it comes to stuff like that, either the building code or whatever program that you're following for those recommendations, with the understanding you can tighten, you can air seal, and air sealing is the biggest thing, but I mean, the most of the infiltration you are going to get is for moisture is from the outside space. And air seal it as much as possible, and always know that a dehumidifier will pretty much help guarantee that it stays in check.
You had mentioned the ACCA low load home program. Is that a standalone that sort of derives manual J, H, and S all within it? Or you had mentioned something like you also need to know those too. So
Yeah.
are those done as an auxiliary to that as well?
Yeah.
Okay, so it's a fourth.
All separate manuals, and then this one assumes, basically you know those other ones, but guides you on all the considerations when it comes to designing and sizing for a high performance low load home. And it's in its first version. It just came out maybe about a year and a half, 2 years ago. So they're always taking comments. I'm sure there'll be revisions at some point, but it is a really good guide to help with that.
And just going back to this sort of high SEER rating piece,
yes.
And it causing, not as much dehumidification. I mean, it sounds like maybe then at some point you're looking at a trade-off of the extra energy used, and I know you got into this, but the extra energy used to have a dehumidifier as a trade-off maybe versus, just a lower AC that's going to get the job done on its own. Do you think that you should even be worried about that trade-off, or just that it's just simpler to go with, both systems?
So I will, so if you go, what we need to understand about air conditioning is there still has to be a sensible load, right? So that air conditioning is only going to run if there's a need for the thermostat because there's a temperature that it has to achieve. So if it's 70 and raining, it's, even if you had a variable speed that, a high-end system with variable speed and dehumidification, if a homeowner walks by a register at 70 degrees and raining outside and there's cold air coming out of it, they're probably going to shut it off.
Right.
So you have to have the sensible load in order to get the dehumidification. Right. So whatever the homeowner's budget will allow, but if you add dedicated dehumidification, you're guaranteed to get to that relative humidity set point. And then you let the air conditioner worry about that sensible load and remove water while it's doing it. But the whole point of building our tighter houses is not to run the air conditioning, the HVAC system as much. It's to lessen those sensible loads. Now we just have to have something to think about the water. And it's probably far more energy efficient to run a 5-amp dehumidifier, which our 70 pine is. Even when the AC systems ramp down and use, less energy, they're still using more energy than that.
So you're really looking at you're not necessarily saying, oh, I'll pick the one with the lower SEER rating because it's going to be better for dehumidification. You're looking at the latent load, right, or sensible, or both?
Yeah, and so what you need to look at when you are looking at the systems, and we have another presentation, but the sensible heat ratio of that HVAC system. So typically I have a slide, and it's a ductless mini split that has all of the specs in a 14 SEER system. Typically, on this chart had a sensible heat ratio of 0.65, I think, which is really good because that's 65% of it is focusing on sensible, and the other 35% is focusing on the moisture. But then when you get up to the 30 SEER system, really energy efficient, it's 0.96. So 96% of its focus is on the sensible and only 4% on the latent. So it's important that we know the sensible heat ratio of that system and how much sensible it's focusing on and how much latent capabilities it has.
Well, Nikki, this is great. I think we've gotten to most of our questions, and I learned a lot, and we have a ton of feedback of people just saying, thank you so much. This is one of the best sessions I've heard on dehumidification. So we thank you for joining us. And just before we wrap up, where can people go to contact you for more information?
Yep, so nkruger@thermistore.com. Also, I'm on LinkedIn. I spend a lot of time on there, so just look for Nikki Kruger on there. And happy to answer any questions I can, and if I can't, I'll make sure that I get you the right answer.
Great, well, thank you so much again. Thank you all for joining us here. Just make sure that if you can, stay indoors, wear a mask, and stay away if you can. We can beat this thing, and we'll see you all in person hopefully sooner than later. So thank you so much. Take care.
Thank you.